Hello, everyone. Today, we'll be moving on with our next topic, type aliases. In TypeScript, type aliases allow you to create a new name for a specific type or a combination of types. They help improve code readability and reusability by giving complex types a clear, descriptive identifier. For example, you can alias a union type or an object structure, making your code easier to maintain and understand. Essentially, type aliases act as custom types that simplify working with intricate type definitions. Now let's see how we can use type aliases with primitive types and union types. First, we define a custom type using the type keyword. We'll call this new type message, and we set its value to be a string. Then we create a variable using this custom type, and as you can see, assigning a string value works just fine. However, if we try to create another variable and assign a number to it instead, TypeScript throws an error because the value doesn't match the expected string type. At this point, we can make use of a union type. We can extend the message type to allow not just strings, but also numbers. As you can see, the error disappears. Next, we create another variable and assign it the value true. This time, we get an error saying type boolean is not assignable to type message. To fix this, we simply add boolean to the message type as well, and now all the errors are gone. Let's check the result in the console. We go to the terminal and run the npx tsc command to compile the code. And as you can see, all of them worked perfectly. Now let's take a look at how type aliases work with arrays. We start by creating a type called number array, and we set it up to accept an array of numbers. Then we create a variable named numbers and assign it the number array type. At this point, we can assign an array of numbers to this variable without any issues. Let's check the result in the console. We compile the code again and check the result. We see that it works without any problems. Now let's take a look at how type aliases work with tuples. We define a type called coordinates, where the first two elements are numbers, and the third one is a string. Then we create a tuple that matches this structure, starting with two numeric values. If we leave out any elements, as you can see, TypeScript throws an error. And if we provide a number instead of a string for the third element, we get another error. Once we structure the tuple exactly as defined in the coordinates type, the errors disappear. Finally, when we check the result in the console, we can see that the tuple works just fine. Now let's take a look at how type aliases work with functions. We define a type called multiply function, which takes 3 parameters, all of type number. According to this type, any function that uses it must also return a number. So, we create a function that follows this structure. It takes 3 numbers as arguments and returns their product. And now, we call the function. If any of the arguments is a string, TypeScript will immediately throw an error. Let's compile the code again and check the result in the console. We see that the result is 105 in the console. Now let's move on to how type aliases work with objects. In TypeScript, type aliases can be used similarly to interfaces. Let's define a new type called person. This type will include 3 properties: a string, a number, and a boolean. Then we'll create an object named person1, and its type will be person. So we'll need to make sure that its properties and values match the structure we just defined. If any of the properties are missing, TypeScript will throw an error. But once all required properties are provided, the error disappears. Later on, we can also update the values of these properties, as long as the new values match the types defined in person. Let's compile the code again and check the result in the console. In the console, we can see that the object works without any issues, and the age value has been successfully updated. Now we create another object using the same person type and add all the required properties. Then we add an extra property to this object, an object type property that doesn't exist in the original person type. As expected, TypeScript throws an error. To fix this, we go back to the person type and add an address property. We can define the structure of address directly within the person type, or, for cleaner code, we can create a separate type for it. So, we define a new type called address. As you can see, the error in person2 disappears. However, now we get an error in person because it doesn't include the address property. To resolve this, we can make the address property optional in the person type by using optional chaining. Let's print it to the console. We compile the code again and check the result. As you can see, everything worked smoothly, and in the console, we can see all the properties and values defined in person2. The nested address object is also handled correctly without any issues. Now let's see how we can inherit the properties of an existing type and extend it to create a new one. In interfaces, we use the extends keyword for this, but with type aliases, we use the and intersection operator. We'll define a new type called new person. By the way, type names can technically start with a lowercase letter, but the common convention is to start with an uppercase letter. Now we want to take all the properties from the person type and also add a new one. To do that, we write person and, followed by curly braces with the additional properties, for example, email. As a result, new person now includes all the properties from person, along with the new email property we've just added. Now let's create a new object using this type. We specify new person and provide the required properties. If we leave out the email property, TypeScript gives us a missing property error. Once we add it, the error goes away and everything works fine. So, what did we do here? We used all the properties inherited from person and added a new one. Now, let's check the result in the console. We compile the code again and check the result. As you can see in this console, everything works smoothly. One final note. You cannot redefine a type using the same name. Let's try to define another type with the name new person. As you can see, TypeScript throws a duplicate error. In contrast, interfaces can be redeclared with the same name. So let's take a moment to highlight some key differences. Types can be used to define both object structures and primitive types. You cannot redefine a type with the same name. TypeScript will throw a duplicate error. To extend a type and add new properties, use the AND operator. So that's how we can use type aliases with primitive types, arrays, tuples, functions, and objects in TypeScript. Type aliases help us write cleaner, more readable, and reusable code, especially as our projects grow. Type aliases allow you to create a new name for a specific type or a combination of types. They help improve code readability and reusability by giving complex types a clear, descriptive identifier. Type aliases act as custom types that simplify working with intricate type definitions. Thanks for watching. Have a great day.